Students, in this video we will be dealing with humidity and its types, and we'll also be dealing with the condensation, different forms of condensation. We'll be dealing with precipitation and its forms, and lastly we'll be dealing with the types of rainfalls like orographic rainfall, conventional rainfall, on cyclonic rainfall, etc. So what is exactly humidity? So it is the amount of water vapor in a given volume of air, or you can say it is the amount of water vapor in the air in a simple term. So it is also an important weather element which plays a very significant role in modifying the weather pattern of any region. Okay, and usually during the hot weather, we feel uncomfortable, uneasy. This is due to excessive, also we experience excessive sweating, okay, etc. So this is due to increase in the amount of water vapor in the air, or and excessive excessive humidity in the air also results into heavy shower. So we can just predict it if there is excessive sweating, or maybe if there is excessive humidity in the air, we can predict that there is a possibility of rainfall. Okay, so the day when we experience excessive sweating, then you can just imagine that there is a possibility of rainfall. Okay, so we'll see the content, as I've already told you what are the content. So starting with the introduction, humidity, meaning of humidity and their types, like we'll be discussing about relative humidity, absolute humidity, specific humidity, etc. And we'll also be discussing about condensation, different forms of condensation like cloud, dew, frost, fog and mist. These are the forms of condensation. And we'll also be discussing about precipitation, different form of precipitation, rain, snow and hail. And lastly we'll be discussing about different types of rainfall: orographic rainfall, conventional rainfall and cyclonic rainfall. So these are the three important forms of condensation, three important forms of rainfall that we'll be discussing in this video. Okay, starting with the introduction. So we know that Earth is also known as wet planet. The reason behind this is 71% of the Earth consists of water. So this we have already discussed in hydrosphere. 71% of the Earth is covered by water, although in the form of fresh water or in the form of brackish water. So this is why Earth is termed as wet planet, or it is also termed as blue planet, etc. So we know that water is very essential for all forms of life. Now water is available on the earth in various forms. So there are three states of water that exist in the earth. They are water vapor form, in the vapor form, in the liquid form and in the solid form. Now this diagram represents the loss of heat and gain of heat during the change in state. Maybe the water is changing from liquid state to vapor state, or vapor to liquid state, or ice to vapor, etc. So when water vapor converts into a liquid state, then it loses its energy or heat energy, that is up to 560 calories. When the water converts into a vapor state, then the heat energy is added, that is up to 560 calories is added. Now similarly, during sublimation process, when ice converts into water vapor, then amount of heat is added is 640 calories, and during the conversion of water vapor into ice in the sublimation process, then there will be loss of heat by 640 calories. And similarly to the in case of liquid and solid, in case of ice and water. Now coming to next, latent heat. So this is a very important term, latent heat. You have been learning in chemistry. There is a term like latent heat in chemistry as well. So what is latent heat exactly? This is the heat required to convert a solid into a liquid or in the form of vapor state, okay, without change in temperature. So when a particular substance is converting into other state, the with the change in the state, like say for example solid is converting into liquid, okay, but what is happening here, the during this conversion the temperature of that particular substance will not increase, it will remain constant. So this is what we call it as latent heat. Latent heat means, latent means hidden, the heat which is hidden in the substance when it converts into different forms, okay. Now this heat is also not recorded on thermometer. That means it is it does, because the temperature is not recorded. So this is why in the thermometer itself this heat is not experienced, or this heat is not recorded. For example, when 80 calories of latent heat is given to ice, it melts and solid is converted into water. Now the heat which required to convert the heat as a latent heat is given to convert into ice, then it starts melting and solid converts into water. But that 80 calorie of heat is not recorded in the thermometer. Similarly, during evaporation, latent heat of 560 calories is a latent heat which is not recorded in the thermometer. So this heat is released in the atmosphere at the time of condensation, which is also termed as latent heat of condensation. Now, so remember this, what is latent heat of condensation? The heat that is released in the atmosphere during the process of condensation, which that heat is not recorded in the thermometer, is termed as latent heat of condensation, okay. So if you want to know about latent heat, you can tell me later on. So I'll make a separate video on this, okay. Now there is a diagram here, you can see, which shows the process of latent heat. Now here, now when solid is converting, changing its phase, you can see here, now this is solid. Now slowly for example say for example this is solid ice, and the temperature of the solid ice is minus 4 degrees Celsius. Now when you supply heat, when you give heat to this particular solid, then slowly that this temperature will rise up to 2 degree, 4 degree, minus 2 degree, minus 3 degree, and minus 0 degree. So up to coming up to that, then what happened, the ice starts melting. So when it starts melting, so during up to this phase, the temperature will stop rising. So now see, it is becoming constant, okay. The temperature is constant. Say for example, the temperature up to here is 1 degree. So after 1 degree, the ice starts melting. So then further you are supplying heat continuously, but still the temperature is not rising. The process of converting the substance from solid to liquid is in a continuous phase. It is converting into a liquid state, but still the temperature is not rising. So this particular phase where the temperature is not rising, the heat which is required for convert the solid into liquid state is termed as latent heat. Similarly, it's happening in the case of vapor, okay. Now coming to next, humidity. Now as I already discussed about humidity is the amount of water vapor present in the air. So the proportion of water vapor in the air is not same everywhere. So it changes from place to place, from time to time. So some places may experience excessive humidity because that area may have water bodies near that. Some area may have low temperature, so thereby there is less humidity. So depending on the places or depending on the time, the amount of humidity varies. So differences can also be less than 1% or about 4% by volume. Now humidity is less in arid areas. Arid areas means the areas that receive less rainfall, less than 50 centimeter, and more in humid regions, especially in the areas where the temperature is very high, as well as there is uh, water bodies. Okay, so we'll have high humidities. Now coming to next types of humidity. Now as I already told you, there are three types of humidity: absolute humidity, relative humidity, and specific humidity. So we'll be dealing with first with absolute humidity. Now absolute humidity is the actual amount of water vapor present in the air. So it is also expressed in gram of water vapor cubic meter. Okay, in 1 cubic meter, what gram of water vapor is there? Okay, this is what we call actual or the absolute humidity, excuse me. So this is the actual amount of water vapor in the air is termed as absolute humidity, and it is expressed in gram per cubic meter. So this is important to note. So absolute humidity varies with the expansion and contraction of air, so due to change in temperature. Okay, now the humidity, generally absolute humidity varies from place to place, and the reason behind this is the air get expanded and contracted, so due to change in temperature. Okay, this happens due to change in temperature. Now this is a theoretical concept, and it is not much used in a day-to-day measurement of the humidity. So for now you have to just understand about the definition of humidity and the measurement or the unit of measurement of absolute humidity. Okay, coming to next, specific humidity. It is the weight of water vapor per, that is weight of water vapor per weight of a given mass of air. That means the specific humidity is usually expressed in gram of water vapor per kilogram of air. Means in 1 kilogram of air, what gram of water vapor is there? Okay, especially in a dry air, in 1 kg of dry air, what gram of water vapor or the moist air is there? Okay, so that is what we call specific humidity. Now it says that specific humidity is not affected by change in temperature in the air. Okay, it is maximum in equator and minimum at the poles. So it's very true. The amount of humidity in the equator will be higher comparative to the poles, because in polar areas, although there are water bodies, but the amount of temperature or the rise of temperature is very less, or the temperature is very less in the polar areas. So thereby the specific humidity in the air will be less. It is more over the ocean than on the land. So nearby the ocean water bodies or over the ocean water bodies, the amount of humidity will be more than the land. Okay, now coming to next, relative humidity. Now what is exactly relative humidity? So relative humidity can be defined in this way: a ratio between the amount of water vapor actually present in the air to the amount of water vapor that air can hold at a given temperature, what we call as saturated humidity. So in this way also you can enumerate this. Relative humidity is equivalent to the actual humidity divided by the saturated humidity, or the air that is saturated, and which is multiplied by 100 to find out in percentage form. So relative humidity is generally enumerated in a percentage form. So you can, I have already given the equation here. Relative humidity is equals to absolute humidity by saturated humidity, or the air which is fully saturated, okay, into 100. So for example, so if actual humidity is 2 gram, actual amount of water vapor in the air is 2 gram, and the saturated humidity is 4 gram, means the air, the maximum amount of water vapor in the air, in that particular air can hold is 4 gram. Then what will be the relative humidity? So obvious that 2 by 4 is into 100 will be 50% humidity. So in that particular air the relative humidity will be 50%. Now depending on the relative humidity there will be a chance of precipitation. If the relative humidity increases more than 50%, there will be a chance of rainfall. If the relative humidity decreases, then there will be a less chance of rainfall. So very obvious that in a dry areas or in the desert areas the relative humidity will be less, and in the tropic region the relative humidity will be more. The capacity of air to hold moisture changes according to the change in the temperature. So this is very true. So next we see the air can hold more of water vapor when the temperature of the air is more. So to have more water vapor in the air, then the air need to have excessive temperature, means the air need to have more temperature. If there is more temperature in the air, then the capacity of holding water vapor will be more. So air is contracted when temperature is less. So air expands when the temperature is more. When air temperature is less, then the air get contracted. So therefore what happen, less amount of water vapor is absorbed in such air. Okay, so if the air is cool, then the air is already contracted, the cavity will be the cavity of the air will not be open up, so thereby water vapor, there is no chance of absorbing water vapor. In case of warm air, the air molecules get expanded, so there will be number of cavities in which the water vapor can stuck there and the air can be loaded with moistures. Okay, so depending on the amount of temperature in the air, increasing or decreasing amount of temperature in the air may it causes or may it results into increase in the amount of humidity. Okay, so for now we'll be discussing only up to relative humidity. So if you have any kind of doubt, you can leave a comment or you can just text me in my WhatsApp number, so I can explain you later on. So rest other video will be discussed in the next class.